want to discuss the balancing of redox reactions, and the reaction I have here is magnesium, which is being burnt in nitrogen, and it's giving you magnesium nitride. So recall from chapter 2 where we first studied the ionic solids. In this case, you actually have magnesium as 2+ and nitrogen as nitride and 3 negative, and basically you bring in the negative charge on the anion right by the cation, and the positive charge of the cation right by the nonmetal here, and that's how you get your formula. So now if you were to balance this equation, this redox reaction, you first want to separate those into the oxidation half reaction and the reduction half reaction. We'll balance that out and then we'll combine them. So let's take a look how it's going to pan out in this particular case. We have magnesium on the reactant side, which is becoming Mg2+. And notice the formula says Mg3N2. That means there is a 3 in front of the magnesium ions. In order to balance that out, I will need 3 magnesiums on the left-hand side as well. You can see that magnesium is going from magnesium neutral to magnesium cations. That means this particular process is going to be your oxidation half reaction. Let's take a look at what's going on with nitrogen. You have N2 as your reactant, and that's getting converted to N3 negative. And there's 2 nitrogens there, so I'm going to put a 2 in front of the nitrogen. But notice both the nitride as well as, so both the reactant as well as the product contain 2 nitrogens, so we are good with that. But realize that since in this case you have a neutral element on the left hand side and an anion, a negatively charged particle on the right hand side, that means it must have come with gain of electrons, and hence I'm going to call it a reduction. Recall, Leo the lion says ger, G-E-R. So loss of electron is oxidation, gain of electron is reduction, and that is the reason why I have labeled them the way I did. Now, we have balanced out the atoms. Our next step is to balance the charge. On the left-hand side, since you have 3 magnesiums and each magnesium brings with it 2 positive charges, in all you have 6 positive charges. In order to balance out the charge, you will need to add 6 negative charges, and the way we do that is we basically add or take away electrons. So you will need to add 6 electrons on the right hand side so that these 6 negative charges basically end up canceling off, neutralizing the positive charges due to the magnesium. Now if you do the same thing for this reduction process, you would probably notice that there's 2 of the nitrides. That means there are 6 negative charges on the right hand side. That means how many electrons should I add on the left hand side? Hopefully 2 times -3 is 6 electrons. And now you have these balanced oxidation and reduction half reaction. So you now simply need to just add the 2 half reactions so that you get a final equation. So now you have 3 magnesium plus nitrogen plus 6 electrons gives you 3 magnesium ions plus 6 electrons and 2 nitrides. The 6 electron and 6 electron cancels off, and what's remaining is your balanced redox reaction using the half reaction method. 2 plus 2 and 3 negative, which can be written as Mg3N2. Just to summarize, step A is to identify the oxidation and the reduction reactions. Loss of electron is oxidation, gain of electron is reduction. You write down the reaction and balance out the number of atoms first. Second step is to balance out the charges. You balance the charge using electrons. So you add the number of electrons in order to neutralize the positive charge or negative charge as the case may be, and you add it to the side which requires that charge. And in the end, once you have balanced the oxidation and reduction reactions, all you got to do is simply add the 2 reactions. The electrons will cancel out, so realize that the balanced redox reaction will not contain any electrons remaining. And in this case, my final reaction turned out to be 3 magnesiums plus N2 gives you Mg3N2. The charges in this case are balanced on either side.